Hello everyone, my name is Reza and welcome to my channel. Quite recently I have received lots of requests about Niagara, the VFX system within Unreal Engine, and why I'm not covering this topic as part of my Unreal Engine series. So I made a decision to record a number of videos on this topic to be able to thoroughly showcase the engine's capabilities. I start by breaking down this topic into smaller digestible chunks and covering the basics of Niagara first and how to read stages, modules, and properties. And we gradually but surely build on top of this lesson in future recordings. So if you have not had a chance to work with Niagara, I highly encourage you to start from this very specific video so everything that we cover after this will make sense. We have a lot to cover, so let's dive right in. I'm going to start by creating a brand new scene. I can go with blank. It's okay to enable ray tracing and starter content we really don't need. I'm going to call the project Niagara and we are going to create the project. All right, here I am in a brand new scene. You may be wondering, where should we start with this? Do we have any buttons or do we have any menus? Well, you can actually start with a blank brand new scene. That's no problem at all. There is no mode or menu set that you need to be in. You can start with any level at any point of time. First things first, I'm just going to right click and I'm going to create a folder under my name, Reza, and then within that I am going to create a Niagara folder so I can put all of my emitters and systems in here. Now let's start our very first Niagara emitter. So that's the very first component that you need to know about in order to start with the whole process. I can just simply right click and go to FX, and here I have the Niagara emitter. I'm going to click and I have three options. Create an emitter and using certain templates to start with, which is certainly a less intimidating way of learning this system. The second one is copy an existing emitter from your project into your brand new project, which is something that we don't want to do. And the third one is to create an empty emitter. Now, while this doesn't provide you with the result right off the bat, from experience I noticed that it's actually the best way to learn Niagara, because it actually shows you all the building blocks, the foundation or the skeleton of the system without having extra modules and auxiliary nodes to confuse you. So create an empty emitter seems like a reasonable start. I'm going to go ahead and finish. Now it's time to rename our Niagara emitter, NE for Niagara emitter, and I'm going to call this my first emitter. Very typical way of naming, of course. I'm going to double click and that takes me to the emitter editor. That's where I actually get to see the emitter itself, the properties, the timeline, the viewport, and some extra parameters that I can add or remove to this emitter. First things first, how to navigate. Right mouse button hold is going to pan. Left mouse button is going to select components, and scroll is going to zoom back and zoom in all the way to 1:1 ratio. Now to zoom in even further, which actually I found useful, is to hold down Control and start scrolling, and then you can see I'm getting more zooms in all the way to 7. So remember, you can always zoom back, zoom in, it stops from 1:1 ratio, holding down Control and zoom in. Within this area, I have this little comment which I can use in order to specify what emitter I'm using. So I can click and have more explanation about my emitter. First emitter I would call. Now, while you can click on this to toggle it back and hide it, the problem is obviously you are using this comment to differentiate. The problem is if I zoom back, this comment is going to zoom back and disappear, which kind of defeats the purpose, because if I have too many of these guys, I want this comment to help me out. Well, a good way to do it is to use this pin. And now if I zoom back, the comment won't shrink. It just stays put, so you can always have your comment with you regardless of how far you would like to zoom on this emitter editor. So that's quite nice. I can just zoom in and click on this toggle comment to hide it. We have timeline, which shows you how long your emitter is going to be active for, and right now it's blue, and every time you see the blue color it means infinity, and the system is controlling it. So the loop situation is controlled by the system, that's why it's blue. You've got the timeline head, and you've got the name of the emitter, and you've got your timeline control, so you can move one frame to the next, to the back. If you have keyframes, you can toggle between keyframes. You can set in and out. You can set it to loop for your playback range, so on and so forth. You have F-curve in the next tab, so you can just look at the function curves that you are going to create within the properties channel. I will talk about that. And then you've got less to some degree important tabs, script stats and Niagara log, just to be able to troubleshoot a little bit and see what exactly is going wrong. So sometimes these tabs are actually very, very important, but you know, at least in a very basic level, when we're creating one emitter, chances are you won't be using those two tabs as often. I'm going to stay within this timeline tab, and let's talk about the components of this emitter. First things first, we have stage and CPU. CPU, obviously, if I click on it, and you can see it here, so can probably give myself more room so we see what exactly is happening. So at the moment, any particles that you create, your CPU is in charge of simulating it. In the future lessons, very soon, we will talk about the benefits of using GPU instead, and what would be the difference between CPU and GPU, how to toggle it, and how to remove any errors or warnings that you may be getting. And then we've got stages. Now, stage is going to add a new stage into this list. So right now, we already have well-defined stages or groups. We have emitter spawn, emitter upgrade, particle spawn, particle update, and render. I can totally go in and add a stage to this structure. So let's say I can create an event handler. So one particle does something and that triggers a behavior for another emitter. And these are the ways that you can actually link one emitter to the other emitter. We will talk about that in future lessons. Obviously, it's way too early to talk about stage. So another thing to be mindful of is you always need to read it from top to bottom. So we create the emitter, and this emitter is going to have certain behaviors, And based on those behaviors, this emitter is going to create particles. And this particle is going to have certain behaviors that we need to tweak. For example, with emitter spawn, there is really not much that we can add at the beginning because, well, spawn means let's get this created. So at creation, what exactly you want to do. So with emitter, chances are we're not going to make so many decisions. So rarely used, to be honest with you. With emitter update, let's say number of particles is something that we sometimes want to understand. So are we going to use 10 particles or 2000 particles? And this is something that we are going to specify. With particle spawn, it's going to be again at creation. What's going to happen when you would like to, when the particles get created? What sort of initial size we're talking about? What location? What color? What would be the lifespan or life cycle of the particles? And once that gets created, we're talking about particle update. And every time you see update, emitter update, particle update, it's after creation, where we're dealing with number of frames. A good example for particle update would be changing an attribute over time. Let's say changing the opacity over time, or translating an emitter over time. And that's something that we can specify within this particle update. So hopefully this makes sense. Let's go to the next chapter and start adding modules within this emitter node right here. Now, while we have these groups already lined up, by default, they're not really doing anything. They're all empty because there is no modules assigned to it. And think of modules as sort of elements responsible for making things happen. So without modules within these groups, you pretty much don't have anything. You have an empty emitter. And that's why in the display, we actually do not see anything. It's pretty much empty. So the first module that I tend to add within emitter update is emitter state. And the way that you add module is by clicking on this plus. You get certain suggestions, and these are most commonly used modules, and then you get a full list of all the modules that you can apply to this particular stage or to this particular group. So I usually start, if I type in state, with the emitter state. Now emitter state sets the expectations for the emitter. It gives you the life cycle of the emitter. You can totally start without it, but chances are that if you add different modules, they will error out and ask for dependencies. And one of the key dependencies is, all right, you would like to have an emitter for how long? So let's sort of make that an automated process. Before we add any modules, let's just throw in an emitter state so we know this goes for how long. And as soon as I do that, you can see part of this blue infinite bar is now a tiny life cycle, which is more like a suggestion, because right now life cycle mode is set to system. So the system still goes through infinity, but if you would like to change it, it goes from 0 to 240 frames. So you can actually see everything inside this module. You can select to see only life cycle or to see only scalability. I'm going to go to life cycle and I say, you know what? I would like to take charge of the life cycle. So I don't want the system to make decisions for me. I would like to do it. So self should be selected. Now within that, you can still go for infinite to say, all right, we are not going to deactivate that anytime soon. Or you can say, you know what, loop that only once, loop duration is fixed, and the duration mode is fixed, and the duration should be more than 1. And look what happens to this green bar once I change this one to 5. So you can see it goes to 5 seconds. And look what happens if I get the handle and try to move it. I can probably zoom in and look at this area right here. If I start tweaking this, you can see loop duration does change. I'm going to reset that one to the original value of 5 and select our module so we don't see extra information in there. So you can see now self is selected and once is selected for my loop behavior. Obviously you can set it to multiple, right, and have that loop go on multiple times, but for now I can just set that one to once. Excellent. I'm going to clear up my filtering right here, and that's how you add a module into a group within your emitter. Let's go to the next chapter. Now we know how to add a module. Let's add more modules and come up with a particle system, or at least a particle in our viewport. All right, so the next module that I would like to add, if I click on the emitter update, is this spawn burst instantaneous. So I'm just going to go ahead and click on that, and just like that I'm creating a stack. So the reason we call that a stack is because modules are processed sequentially from top to bottom. So while I'm making that stack, you always need to remind yourself that the one at the bottom overwrites any common attribute from the one underneath, if there is any overlapping attributes. And whatever you do, the first building block is the first one that you're creating. At any point of time, you can go in here and rearrange, and you can see as soon as I rearrange, then I'm changing this stack, and that may not work well within my emitter system. As a matter of fact, if I just go ahead and press delete on the emitter state to just have spawn burst instantaneous, I'm getting an error saying that the following predependency is not met because there is no life cycle. And that was the reason behind me adding the state module as my building block, my first building block within this emitter update. You can always go and fix issue and it adds the emitter state for you. But again, understanding the sequential order and why we add certain modules first is always important. So I can go into system and pick self and go to infinite and pick once, and we just leave it at that. You can go and change the leave duration to, or a loop duration, excuse me, to whatever you want to have. It really, there's no right and wrong here at this stage. We're just testing. So that's that. Now, spawn burst instantaneous. As the name suggests, it creates burst of particles at the same time. Now it says, how many would you like me to create? We can say 1, 2, 3, 10. It really doesn't matter. But keep that in mind that this module adds them at the same time in the same location. Now you may say, Reza, what is happening? Why I'm not seeing anything in here? Because we have an emitter. Maybe we should sort of create a particle. Yes and no. Before we get into particle spawn and particle update, let's talk about render actually. And render defines how the output will get displayed. We have different types of render types, or the way that you see the particle. We have sprite, we have mesh, we have ribbon, we have light, we have geometry cache. As a matter of fact, if I click on this plus to add, a new renderer, you can see that we have sprite, ribbon, mesh, light, geometry cache, decal, and component. Now, the most common one is a sprite and the cheapest one is sprite. Why? Because it actually gives you this, and you may say, yay, we've got a particle. This is not a volumetric particle, although I can just move around and basically see the particle, and looks like it's a 3D object. In fact, that is not the case. It's just a 2D sort of camera faced plane. So just like any sprites in other software packages like Maya, it's just a 2D plane with a material assigned to it. If I click on reset the default, you can see all I have all of a sudden is a plane that has been aim constrained to the camera. I can press Control Z, and if you would like to take a peek at this material, you can always go into Browse to find default sprite material. You can just minimize it right here. You can see the Unreal Engine found this material for us. It's under Niagara content, under plugin, under engine content. So if I scroll all the way up, you can see it's under plugins and it's under engine content. So if you would like to see it, make sure that your show engine content and show plugin is enabled, so you kind of get to it and you can see it. But this would be the trick later on to create simple effects. We use Sprite. We, let's say, attach a puff of smoke as a material, and we multiplied them, scattered them, and direct the movement of them using force field, and we get to create simple effects. And it's, yes, that easy. So now we have this. Let's go into particle spawn and particle update and see what else we can add to create particle and eventually move them. All right. With particle spawn, it gives us the opportunity to specify important attributes, including the size of this particle, because in the emitter, we can just have control over the length and how many particles, basically the rate, but no attributes to control the size. And that gets created or controlled through a module that we add under particle spawn. So if I click here, you can see we've got some basic ones. I again tend to start with initialize particles. So if I type in, you can see initialize under initialization, initialize particle is there. And that initializes common attributes. Again, it sets the standard for the particle system that you're about to create. Lifetime mode, and you can just set that to random or a set value. And remember, this is the life cycle for your particle. Don't confuse that with the life cycle for your emitter. So if you have a life cycle for your emitter, as soon as this life cycle ends, everything will vanish. But if the particle gets a life cycle, this particular particle may vanish, but the one right next to it may still be alive, especially if you have a random situation where you say one lives for 1 second, the other one lives for 2 seconds. So don't confuse the two. You have color, but I have way better methods to assign color to our particle, so I'm not going to talk about that. So we have, again, control over the sprite size, sprite rotation, and sprite UVs. And you probably now know why I talked about sprite renderer now, because we've got mesh attribute and ribbon attribute. And if you remember, we had ribbon and mesh renderer. So technically speaking, we are not going to talk about this if you have sprite set as our renderer. Another way of doing this, instead of looking at all of these and feel overwhelmed, you can go and click on these tabs and go through the whole thing one by one. Again, at least for this lesson, we're not going to talk about these two. Definitely in future videos, we have to go and explore these two options. With point, let's set the lifetime and let's set the sprite size. At the moment it's unset. You can make it uniform, random, non-uniform. Let's say I'm going to go with uniform, and all of a sudden we've got a smaller particle. I'm just going to set that one to 20, 30, and keep looking at this area right here. You can see how the particle gets bigger and bigger and bigger. Rotation mode, very useful, especially the random one when you have a texture instead of this solid color, because then you don't want every single texture to look exactly the same and face the same orientation. You want to sort of rotate it around. So right now it may not make sense, but eventually it does. And if I go back to point, I set the lifetime to 1. Probably I'm going to just increase it to 2. And that should do it for this particular example. So initial particle, quite useful. Now I'm in particle update. The first one, just like emitter update, is the state. So I would like to go in here and type in state, and I would like to add particle state. And the good thing about particle state is it just, if I ever so slightly go in here, it kills particles when lifetime has elapsed. So to tell you the truth, is one of the most important modules that you need to add so you don't run out of memory. So it automatically kills the particles when lifetime is finished. Perfect. What else can we add? Let's add one of the modules that actually makes things a little bit fun. So scale color is what I like to add every now and then if the situation calls for it. And that gives you control over changing RGB and changing alpha, in this case opacity. So I can go in there and change this number 1, which is solid or opaque, to 0.5 to 0.1, and you can see it's gradually but surely fade. But wouldn't that be nice to sort of have that over time instead of just one fixed value or absolute value throughout these 5 seconds? I'm going to go and click on this arrow right here to have access to some suggestions here. One of these suggestions says float from curve. So what it does, and you see that in Niagara a lot and we use it a lot, it looks at a value and it converts it to a function curve that you can tweak over time and add interactivity. So instead of adding manual keyframes to frame 0 all the way to frame 240, you just convert it to an F curve, and you can just change the F curve over time so it plays around with the value over time, just like a, let's say, a graph editor inside Autodesk Maya, if you are familiar with that application. So float to curve, and look what happens. It gives us in frame 0 a value of 1. And as I move forward, look at the, if you're not sure if you can read the tooltip, it goes from 0 to 0.5, 0.3, 0.2. And when I reach 1, the value is 0. And 1 is pretty much the end of my particle cycle. So if I play, you can see how it vanishes. 1 opaque to 0. 1 to 0. So you can see how useful this can be to add interactivity and finer control over what you do. If it's hard to see this window, you can always click and show this curve in curve editor right here. So I can actually even move it up and plug it somewhere else, let's say here, or I can just move it to my second monitor if need be. At the moment, I'm going to leave it here. You can add and fine tune this curve by middle mousing to add a keyframe, right? So a lot can be done. I'm going to undo because I really don't want to mess this up, but a lot can be done. You can select each keyframe, right click on it, and change the interpolation. For example, I can select this one and press 1 on the keyboard and get a tangent to play around with how quickly this transition, whatever transition I have, is going to happen. So having that F curve using float to curve will add lots of possibilities and flexibilities to my particle update. All right, I think it's a good time to talk about Niagara System. So basically, if I try to put my emitter onto this level, I simply can't, because it needs to be encapsulated within a Niagara system. And that Niagara system is like a container that you can store one or multiple Niagara emitters inside it. Now you have two ways of doing this. One is to create a clean Niagara system and create a clean Niagara emitter inside it. The other way is to use the existing Niagara emitter and place it inside a brand new Niagara system. Let's explore both. Let's do a clean Niagara system with just a template Niagara emitter. And that's very easy. You just right click, you go to Niagara System to create a brand new Niagara system. You can do it through Effects, Niagara System, or you can access Add button, Niagara System here, and from Effects, Niagara System. And in here, you can just create a new system with emitter templates. I'm just going to go New. And in here, you can choose a preset. I'm just going to pick a simple sprite burst, which is very similar to what we've been creating so far. But right now there is no emitter. You have to either click on this green plus button, well, green rectangle with white plus button, or you need to double click on it to create the emitter, and only then you go finish. You can see the icon is slightly different, saying that, all right, it's more like a container, have more of these stars icon in it. If I double click, you can see I am inside the Niagara system right now, which is the layout is kind of similar. So you're still dealing with parameters on the bottom left, the display or preview window on the top left. I've got my timeline and curve editor on my bottom center. The Niagara System overview window right in the middle, and the parameters and properties window on my right hand side. So that's the sort of a typical layout that we're dealing with Niagara. But I have the preset that I've made, which you can see it's very similar to what we created so far in this lesson, and a Niagara system with state already added. And remember, that's something that we did. We created emitter state, we created particle state, and I mentioned that it's one of those modules that we tend to add. It needs to know its life cycle, and you can see the life cycle is right here at the moment. So I'm just going to pause this so it won't run forever. But that's how you create a container, and that container holds something. But what if I want to use my existing particle here and add it to this system? Because if I go to Content Drawer and try to drag and drop it and include my existing emitter into my new system, I simply can't. You have two options. You can convert your emitter inside your Content Drawer and create a brand new system, or you can use your existing system. I'm going to just delete this one and bring your emitter here using the letter E. So I'm here, I'm pressing the letter E, and it says add emitter. Well, all it takes is for you to search for your Niagara emitter. If I just do that, it's not going to bring anything because it says library only. I'm going to turn it off. I'm just going to say that, all right, this is my emitter, and I'm going to go to parent emitters, not the templates, and there I have my first emitter. So that's one way of bringing your emitter into a clean system. Or if I don't want to do it this way, I can just go in there, select my emitter, and right click on it, and it says I'm going to create a brand new Niagara system, and I'm going to put your emitter that you're selecting right now in it. So I'm going to create a second Niagara system. Now I don't know which one I created. There you go, that's the one. And it inherits the name, puts my Niagara emitter that I've selected inside that system. So I'm just going to get rid of the empty one because I believe I already put my Niagara emitter inside a system, and now I should be able to drag and drop my Niagara system inside the emitter with no problem at all. Right now the gizmo doesn't allow me to see the single particle that I've made, so I can easily go in there and say game view, and you can see the particle does show up. All right, let's go to the next module and push the pedal a little bit. Let's get a little bit faster, add a few more modules inside my emitter, and come up with something interesting. All right, let's go ahead and add a little bit of interactivity to our simple sprite burst. First things first, I have problem with this burst instantaneous because it's really difficult to separate those particles. They get created at the same time and die at the same time. Not the most exciting module. I can easily replace that with something very similar, and it's called spawn rate, which does kind of the same thing, but with this you can actually specify number of particles. And what I can do with this one is I can just simply disable the module. You can totally select it and press delete on it. Non-destructive approach is to just disable it, and if you want to go back to it, you don't need to recreate it later on. So with this spawn rate, a number of particles, let's say I just want 50 particles. Another issue is the emitter dies really soon, because remember we set the emitter life cycle to just live only once for 2 seconds, which is quite short. So what I can do is to go to loop behavior and set that to infinite. And of course, another method is just to go to life cycle mode and set that to system. I tend to keep that to self and just go with infinite. With that, I can just toggle between infinite, loop, and multiple number of loops. All right, we're making progress. Now, how can we move it? Well, you have two ways of moving a particle. One is to add initial velocity into a particular axis or multiple axes, or you can use force field. Let's start with the easy one, which is add velocity. Now, think about it, where we should add the velocity force. If we put this under update for emitter, emitter generates particle, and that's it, really. So there is no space or room for velocity. As a matter of fact, there's a much easier test. If I just type in velocity, nothing comes up saying that, all right, velocity doesn't get applied to an emitter. Velocity is something that you apply to particle. You can do it at creation, you can do it during its life cycle. We're going to do it at creation. So you can see even in the suggested list of modules, add velocity is the first one, because it's a very common module to add to simply move your particles. If I go add velocity, it comes up with as an error saying that, all right, I need a post dependency just to be able to calculate the velocity, because yes, you added the velocity and you are going to set a buoyancy, so on and so forth, but how will I be able to calculate it? To do that, you need to add an important node after creating the particles. So particle update would be the right space for it, because we're going to do it during its life cycle. Just type in solve, and it says solve your velocity and all of your forces. As soon as you add that, the warning goes away, and you can see that the particles are now going crazy. And they've got different sizes, because in initial particle, I set the sprite size to random. You can do uniform, which is kind of boring, and you can do random, 5 minimum, 10 unit maximum. You can just play around even further to break up the sort of boring look. Now you may say, Reza, why it's so straight? It's coming from the velocity itself. We have velocity mode set to linear, straight line. You can emit from point, which is like omni. If I click, you can see we get those particles distributed in all directions from a point, hence from point. You can do it in a cone. So it's more like a directional emitter where you get a cone angle and you get cone axis. So we've got cone axis and cone angle. Right now it's emitting towards X, positive X. We can say don't, just emit towards Z, which is up axis. You can play around with inner cone angle, with the actual cone angle. So we can say widen the cone. So you sort of change the spread to 80 degrees, or make the cone quite tight, which is like 15 degrees, almost a straight line. So that's the opportunity that you have to play around with this. Of course, at any point of time, because we have scale color, if you wish to sort of kill those particles early, you can just play around with this F-curve and bring it in, and you can see the particles die earlier. So I can just bring it down so you can see what's going on. That's the beauty of having this float to curve, because it's so interactive and you can just easily change the dissipation or buoyancy of your particle system. Now, remember that I told you that velocity is not the only method to create interactivity. You can do it with force. Now, before I bring in a force, I can just simply deactivate my velocity, and let's break up this particle using something more than initial velocity. And I'm just going to pause. We have something called location. So if I bring in location, we have shape location. So one reason that I brought velocity was to separate those particles. You can do it with location. So specify a fall off, a range, something to place particles within that volume or location. So shape location totally does the trick. So it gives you a volumetric shape like sphere. I can probably go to emitter update and expand it, go to spawn rate and give myself more particles to work with. Let's say 300, maybe even 500. So you can kind of see the shape clearly. You can do sphere, you can do cylinder, and you can totally see the shape of the cylinder. If I increase the height to, let's say, 300, now you can see how easily you can create a cylinder looking particle emitter. You can do box, and of course every time you change those shapes you get all the sort of related properties to tweak the shape. For example, box size. If you feel like this box size is small, you can do totally 300 by 300 by 300, or you can create a rectangle if you want, and all of a sudden you get a much bigger box. You can do, let's say, torus, and of course you get the radius. So I can just do 10 and 200 to get a much larger, thinner radius. And it's more like a ring of particles, which is quite interesting. And again, you always have transform if you wish to, let's say, rotate it. So I can do axis angle and say, all right, I would like to rotate that. I'm now rotating it in y-axis. So I'm creating a ring like that. Now, let's say I'm going to switch that to good old sphere, because there is a lot that we can do with this sphere right here. Sphere distribution, random and direct, which is actually going to create that for me. I can go in here and change the V position. I can change the radius position right here. With U position, you can see that you get that a lot, where you get this linked value. It says it's linked to the emitter. So if I play, it's going to actually complete the ring. So this gives you the cue that, all right, it's been linked to the emitter, and age, or as you go through the life cycle, is going to complete the picture for you. You can click on this and sort of change that. Float to curve again is an option where you get a curve into your curve editor panel, and you can play around with it. I'll let you guys have fun with this shape location, but for now, let's move on to the next chapter and explore forces. So now we explored how to simply move particles using add velocity. Why don't we try force fields? Force fields give you much greater tool set and options to choose from. So for now, I'm going to deactivate add velocity. So if I just rewind and play, I'm really not getting anything. Particles just get created using spawn rate, and what I've specified to spawn rate, 800 particles right now. So let's think about it for a moment. Where do we need to add force field? Because based on where you put the force field, it's going to either work or doesn't work for you. Let me just switch that to torus so we get a much better result when we add a force field. We go to update, particle update, and we can add force field here, and we don't need to add any post dependencies for it. You can see we have drag, we have curl noise, which is like a turbulence, works really well. We have vortex. Oh, let's use vortex. It's just fun. We can see that we have the amount, which is the intensity. I can lower it to, let's say, 100. I can just go rewind, play, and you can see vorticity takes place. You can have more modules. I'm going to stop, go to particle spawn, shape location, and tighten this torus. So probably put 5 for this 150 for radius. I'm just going to lower it to say 50, just to be able to get a much better result. Right, it's more like a galaxy-ish looking. Fine. While we added, why don't we add colors? With colors, I tend to put them in particle update as well. So just simply search for a color, and this color is going to overwrite scale color. Always think about that, because again, it's a stack that we're dealing with in a sequential order, top to bottom. So whatever you put at the bottom will overwrite the top. So it will overwrite this node. In color, we're dealing with the same thing. We're dealing with scale alpha, and we're dealing with color. You may say, Reza, are we going to get something like float to curve with this one? If you click, you get color from curve. And if I go in there, the top is the color and the bottom is the opacity. So if I move this bottom chip, I will play around with the opacity. So I can just make it, this is the start of your particle system, this is the end. I can sort of change the opacity. You can see how it impacts within the preview window. And this one is actually the color itself. I can double click on it and say, when I start, I want these colors to be orange. You can add colors, so you can just click and say, well, as we move through, I would like these colors to turn to red. And you can see at the beginning, it's orangey looking. As we moving, it's red. You can do, so kind of go in here and swap and say, all right, no, you know what? I changed my mind. I want the beginning to be red, and you can see the feedback live. And as we go through it, I just want that to be orange, and you can add another one and say, you know what? After that, I want that to turn to pink bluish, and you just play around with the range as you go. You can play around with opacity to give this more life to the life cycle, or you leave it as is and start tweaking those colors. So that's basically it. It's just really, really easy, really fun, quite simple to play around with. Let's say you want to add chaos to the whole system. So particle update, I can go into forces and I can just say, you know what, I would like to add a curl noise to it. And curl noise simply adds chaos. Noise strength, I can just zoom in so you guys get to see what's going on. I can set down to 50 and you can see there's a little bit of chaos happening. Some particles shoot off to different angles. You can lower the noise frequency to see it in a more exaggerated way. And you can see we give it a little bit of a bend that is happening right now. So a lot can be done. I can go in there into initialize particle in my particle update, initialize particle. I can play around with min and max. So I can make the min 2 max, let's say 10. I can go to spawn rate and bump it up to 2000 or let's say 4000 particles and just have fun with it like that. So a lot you can do at the same time. You can switch to unlit to see the colors only and see the result. And it's just one of those things that there is no end to it. Just a quick note, if your machine starts struggling with your spawn rate and you feel like you've got a decent graphics card to swap your calculation from CPU to GPU, you totally can. You can go to GPU compute sim and it says, well, you know what? The bounds mode is dynamic and it only works with CPU. You can just switch to fixed. And if I play now, I'm now playing via my GPU. So that's pretty much it. How you add interactivity using, so I'm just gonna move this one a little bit here. I can probably go into curl noise and start tweaking stuff here and there. And you can see I'm coming up with some fun results. I'll let you just have fun with it. You can combine that with add velocity. So I can go add velocity, set it in cone, and you start sort of playing around with this, with colors. So I can go to colors and say, you know what, I just want to turn that to something. You have linear sRGB to play around with, and that should really do the trick. So I'll let you play around with this and get all sorts of fun results. Once you're happy with it, you can just simply save your particle and just drag and drop it in and see the results like so. So hopefully this is going to give you all the basics you need to know about Niagara System. We barely scratched the surface on this topic, and that's why I thought having this session is quite necessary to be able to explain the main building blocks, explain the core components of Niagara, and hopefully from next and future lessons, without being worried or too concerned about, oh, we don't know what module is or we don't know what Niagara System is, we can just focus on specific effects and look dev and just have fun with the system. I really hope you found this video useful. Please go back, try different modules, have fun with it. I'm 100% certain that you'll come up with something much better than this. Of course, this will do for just the introductory session. And thank you again for all of your support. Follow us on Twitter and Instagram and Reddit, and support us through Patreon. Thank you so much, and see you guys in the future lessons.